problem from our arithmetic notes from last time, right? We're going to finish this, okay? So, number 1, it says the first row, number 11, says the first row of a concert hall has 25 seats, and after each row, it increases by 1, right? It becomes 1 more than the row before, okay? So there are 32 rows of seats. You know, I know you guys don't really like word problems. The thing is, word problems aren't bad. You just have to figure out what they're telling you. And if you need to, draw it out, right? So the first row, so row 1, right? Okay, I should probably just write it as r equals 1. The rows. There's row 1. How many seats are in row 1? 25. So then row 2. How many seats then? Well, look, it says each row after the first has 1 more than the one before. Yeah, so then the next one has to be 26. And then the third one, 27. And then the fourth one, 28, and so on. How many rows did they say there are? 32 rows. Okay, so there are 32 rows here. Who knows how many seats there are in 32 and have to keep adding up, right? So here's the thing. We need to write a rule for the number of seats in the nth row. So the row, this is your n. Yeah? And these actual numbers, those are your a sub n. Remember I told you if you have the a with your n, I want the actual number, right? Not just the row or the place number. I want the actual number. So if I look at this sequence is really 25, comma, 26, 27, 28, and so on up to 32, right? So tell me, a sub 1 equals what? What is the first number in this sequence, in this list?
25.
25. And guys, what is D? What is my common difference? So 28 minus 27 is what? Positive 1, right? What is 27 minus 26? 1. And 26 minus 25? 1. See how that number's the same? That's your common difference, right? It means it's adding 1 each time. So writing a rule, this is talking about your explicit rule, okay? And if you look on your color sheets there, your tan color sheets, right under arithmetic, that first formula, that's your explicit. That's the one we're going to use. So a sub n equals a sub 1 plus n minus 1 times d. Yeah? A sub n equals, what is a sub 1? What did we find?
25.
25 plus n minus 1 times, what is d? Huh? 1, thank you. And since we're finding the formula for the nth term, we have to leave the n's, right?
Yeah.
All right, so let's distribute. So a sub n equals 25 plus 1n, which is just n, right?
Yeah.
And what's 1 times negative 1?
1.
Minus 1, right? And then you have a sub n equals n. What's 25 minus 1? You gotta combine like terms, right?
Oh, yeah.
24. So that right there, right? That is my formula for the nth term. So now let's look at b. Guys, if 35 students want to sit in the same row, right? Then which row do they have to sit in? All right. So then they're saying, okay, here for A sub n, they want to be 35 here, right? So what do we need to know? Which row, right? So then what are we looking for? Are we looking for A sub n or are we looking for n? N. We need to know n, right?
And plug it in.
Huh?
Don't you already have that?
Well, we know all the n's, but which n can they sit in so that all 35 of them can sit there together? Right? Well, yeah, we got to see where, right? So, 35 students, we're going to plug it in here, right? Equals n plus 24. Yeah, I guess you're right. I guess I should have said a range, right? You know, with first period, we talked about the first one where they can all sit together. So we'll put that and then we'll discuss the range. Thank you, Ethan. Right? All I did was plug it into the formula. But A sub n, which is the number of seats, is 35. So I plugged in 35 there. How do I solve?
Subtract.
Subtract. So then n equals what? 11. So the 11th row is technically where they can first all sit together. Yeah. So any, I mean you can. Any row from 11 to what, Ethan?
32.
To 32. Okay. Shoot. First period, I only said row 11. First period, I hope you're listening to this. Any row from 11 to 32.
Wait, I have a question. I remember like last year, like after you did a word problem or that before, like you put like three little dots or that.
Therefore. Because last year you took what, geometry?
Yeah.
Geometry, they do a lot of that. That's logic stuff. All right. How many seats are in the concert hall? Guys, are they just asking you for one row?
Every row.
Every single row, all the 32 rows, all the seats in every single row, basically the total seats, right?
Yeah.
So which formula do I have to use?
First one.
No, the first one only tells you once. Yeah, the sum, right? The total, the sum. We're going to use the fourth one. So I need to use this guy. S sub n right? And tell me again. Okay, so n equals what? How many rows do we have? Total? 32. Thank you, Sabrina. A sub 1, what was the first number of seats in the first row? 25. And what is D? 1. So now I can plug all those in, right? S sub n equals, what is n? 32. 2 times 25 plus n, which is 32. If you need to get water, you absolutely can at any time, okay? Times 1. And I just wrote out the 1 because, well, that is my common difference. Oh, oops, I should have written 32 right here. 32 over 2 times what? What is all of that inside the brackets when you put it in the calculator? This, because we want to shorten it down, right? Ethan, did you get that? Because I saw you working hard over there.
I just did a more simple way with one answer.
Did you? What did you add up all of them? Ah, you're supposed to use the formula. But I'm sure you have.
81.
Is it 81?
Yeah.
Okay. So now what's 81 times 32 halves?
1296.
Huh?
1296.
1296 seats total in this concert hall? Is that what you got?
Yeah.
See, and you can do that because they're only 32. But if they said like 50, well, I guess only as well as you can. There's so much time.
I mean, I think I did do it faster. So.
But no fair, we a little slow today. Alright, so any questions? Alright, so this is arithmetic. Today we're going to do geometric. Everyone. Alright.
You should try T.
So, geometric. So, remember arithmetic, I told you it adds the same number from number to number, right? With geometric, it multiplies the same number from number to number, okay? So, and in geometric sequences, it doesn't have a common difference now, it has a common ratio, which is denoted by R, okay? So, same thing as before. N is the place in line. You have 64, 32, 16, 8, and 4. A sub 1 means the first number in line, which is what? What's the first number in line?
349.
A sub 2 gives me the second number in line, which is 32. Yeah? If you want to know what the common ratio R is, start from the back.
So for that one, it's half, right? You divide it.
Divide. So you have 4 divided by 8. And what is that, Tom?
Half.
1/2. So that means it multiplies 1/2 there. Okay? Let's try the next one. Remember, and it has to be consecutive, right next to each other numbers. So 8 divided by 16 gives me what? Alright? You guys start from the back and divide the one right in front. That should also be 1/2, yes?
Yeah.
Now do the next one. 16 over 32. That gives me what?
Half.
Good. And then the last one, 32 over 64.
Half.
Half, yeah. So your R, or the common ratio, is 1/2 for this sequence. Alright? So,
The next one is,
let's look at the next one.
yeah,
Alright, well let's see. Let's see if we can figure this out. Is it geometric? We'll start from the back and divide the one right in front of it. See if you get the same number each time. 162 divided by 54. And then try 54 divided by 18. 18 divided by 6. 6 divided by 2.
Do you want us to write the common ratio for each geometric?
Yes. So what did you get?
Okay.
3. Are you not putting it in? Are you just,
No.
right? Right? It is geometric, and my ratio is 3. Because remember, going this way, going from left to right, it has to multiply. So 2 times 3 gives you 6.
Yeah.
Not a third, right? 6 times.
Oh, that was the other way around, right? It went back every line.
Alright, so look at number 2. Does that one have a common ratio? Is it geometric? Well, let's see. 36 divided by 12. What is that? That's 3. But look at the next one. What is 12 divided by 6? 2. Well, then that's not the same number, right? So no, it's not geometric. There is no common ratio R, right? Okay, so this sequence is a geometric sequence, okay? That's what they're telling you. 3, 6, 12, 24, 48. Alright, so guys, this is n equals 1. That's 2, 3, 4, 5. Oh, the next one is 6, right? They want you to find the 6th term. Well, first you gotta find R. What is R here? Huh?
Two.
2, yeah. It multiplies 2 each time, right? Or you can work backwards. 24 divided by 12 is 2. 12 divided by 6 is 2, right? R is 2. So then, what does that mean? What is my next number? Times 2, which is, what's 48 times 2?
96. And the other one is 63.
So let's see. 6, 7, 8, 9, 10. It wants you to find a sub 10. If you know that a sub 6, the sixth number in line is 96, then use that R times 2.
192.
Alright, use that and see what the 10th term is. And what did you say it is, Tom?
It's 192, and then, oh, I thought we were going in the order from 6 to 10. We're just going to do the other.
What? Hold on, you're shouting numbers at me. I thought you had, hold on. Let's give everyone a second to fill in the blanks, okay?
That's what I thought we were doing.
You have no clue? Okay. Do you know where we got 96?
Yeah,
Okay. So now, that was the 6th term, right?
You multiply
Now we're
it.
looking at this. Find the 10th term. So all I did was draw it out. If I know that the 6th one is 96,
You multiply by 2.
yeah, right?
Yeah.
If your R equals 2, it means you're multiplying by 2. So what's 96 times 2?
192.
Alright, Tom, give Abner a chance. And then that times 2 is what? I know you know it. We gotta give other people a chance too, right? Huh? 384. So Tom, you can check and make sure. Alright? What's 384 times 2?
768.
Go ahead. What is it?
768.
That what?
768.
768. And then times 2, I think Ethan said it earlier.
1,532. I mean 36.
Alright, so a sub 10 equals 1,536. Tom, is this right?
Yes.
Alright, Sabrina, you got it too. Good. Cindy? Alright. So, that's what we did. We okay? Yeah? Huh? Still no? Let's try it with the formula. The formula is actually not bad with the geometric. So the nth term of a geometric sequence, right, this formula, guys, is the first formula under geometric on your tan color formula sheet, okay? So if I give you this sequence here, all right, they told you it is geometric, right? So they want you to write the rule for that, and then they want you to find a sub 11. So find the 11th number in this list. Okay. First off, let's find a sub 1. What is the first number in that list? Good, negative 12. Now, what is R? Let's find R. Start from the back. Divide the 1 in front of it. What's negative 27 divided by negative 18? What'd you get? Put it in the calculator then if you need to. Math enter, enter. Math enter, enter.
3 halves.
3 halves. And then do this one. Try that one, you know, just in case. Negative 18 divided by negative 12. Does that also give me 3 halves? Yes. Cindy says yes. Good. It should, because this is geometric. So then that means my R equals 3 halves. Do you agree? All right. So to find the rule, plug it right back into that formula. You want the ends so that you can plug in whatever end, right? So we're going to plug it into a sub n equals a sub 1 times r to the n minus 1. Okay? And then that becomes a sub n equals my a sub 1, which was negative 12, times, what's my r? 3 halves to the n minus 1 power. That's my rule. That's it. That's all you have to do. Okay? And then to find my a sub 11, you see plug in 11 for n. That's it, into that formula. So negative 12 times 3 halves to the 11 minus 1 power. Right? All you have to do is just plug it into that n right there. Okay. Which gives me, and literally you could just plug that right into your calculator. Guys, don't multiply, let's write that here. Do not multiply a sub 1 and r first. Okay? This is never negative 12 times 3 halves to the 10th power. It's not that. Okay? Because order of operations, right? Remember PEMDAS tells you parentheses, exponent, and then multiplication. Right? So really what you should be doing is 3 halves to the 10th power times negative 12. Does that make sense? But if you put this into the calculator, your calculator does order of operations and everything for you. So let's put that into the calculator. Let's try it out. We're going to put negative 12 times 3 halves to the 10th power. Let's put that in the calculator. It can't be all or nothing, right? Got a weird decimal, did you? All right, turn it into a fraction. See if we can get into a fraction. It'll be more precise.
Wow.
It is
How come you're so good?
a pretty small number though. Isn't it? 'Cause it's negative. Negative, right?
How come you're so good? It puts a caret next to its hand, and it's a fraction, it's a big fat.
Because I don't have math. All right, so what is it? What's the 11th term? Negative 177,146. Is that right?
Yeah.
Over what? 256?
Yeah.
No, 147 or 146.
Just 256.
What? Did I write it wrong?
177,147 over 256.
7. All right. Any questions? All right, let's try the next one. So, write the rule for the nth term of the sequence. Guys, geometric is way easier because all you have to do for the rule is just plug it into this guy. Right? That means you need to find a sub 1 and you have to find r. All right, what is a sub 1. What's my first number in this list? 100. Thank you, Sabrina. What is R? So, start from the back. Yeah, you see how I have that fraction? I mean, you could skip it, but you could just easily put it into the calculator. It's just 25 divided by 2 in parentheses divided by 25. You want to see it?
45.
So 25, you got 5 by 2 divided by 25. 0.5, which is 1/2, right? Is it the same when you do this? 25 divided by 50? You get 1/2?
Yep.
Okay, so then I guess I could say my R equals 1/2, right?
Yeah.
Alright, so then let's plug it in. A sub n equals A sub 1, which is 100, times R, which is 1/2 to the n minus 1. This is your rule. That's it. For this, there's no distributing. It's just plug. Alright? Okay, and then find A sub 7. What are you going to do with that 7? Plug it in. Plug in 7 for your n into your formula. So you have A sub 7 equals 100 times 1/2 to the 7 minus 1 power. So what is 7 minus 1?
6.
Yeah, so it's really 100 times 1/2 to the 6th power, which gives me what? So you should have 25 over 60. Yes?
Yep.
Alright. Alright, so just like we did with the arithmetic, right? What if you were given just like a random number like this? They gave you the 7th number, not the first, right? But they gave you R. Well, now they want you to write the rule. Well, then you need A sub 1, don't you? You always need that first number, right? So we're going to use the same formula, and we're going to find A sub 1. So we're going to say A sub n equals A sub 1 times R to the n minus 1. Yeah? Guys, what do you know? You know that A sub 7 equals negative 1,458. Excuse me. Oh, excuse me. R equals negative 3, right? So, let me see. This 7, well then that's my n, right? So then that's my n, well then that's also my n. Yeah? My R is negative 3, right?
Yeah.
But the thing is, you can't have these two A's here. Do you know what A sub 7 is? What is the 7th number? Look, A sub 7 is,
8.45.
yeah, negative 1,458. So then that equals A sub 1 times, what is that, negative 3 to the, what's 7 minus 1? 6. Right? Do you see how you're going to be able to solve for A sub 1? Find negative 3 to the 6th power. That has parentheses around this, so please make sure you put parentheses. What is it? What's negative 3 to the 6th power? 729. Thank you, Ethan. How do I solve for this A sub 1? How do you solve for that that a sub 1? These two are multiplying. So what do I need to do?
Divide.
Divide. So a sub 1 equals what? What is this? Huh? Is it -2? Thank you. -2.
Yep.
So guys, look, now you know a sub 1 and you know r. So now you can write the rule. Because all you have to do is just plug in a sub 1 and plug in r, right? So then the rule, a sub n equals a sub 1 times r to the n minus 1, right? So a sub n equals, what is a sub 1? No. Oh yeah. Sorry. What is r? -3. To the n minus 1. And that's it. Leave it. Do not multiply the -2 and the -3. Just leave that, right?
Yeah.
Good. That's it. Is this better than the arithmetic, or which one do you guys like better?
Arithmetic.
Do you really? Alright. Alright, let's try this one. Alright, I'm going to work a little bit faster through this one then, okay? Think about what we know. We know a sub 10 equals 7,680. We know that r equals 1/2. Guys, you need to find a sub 1, right? So I'm going to plug it into a sub n equals a sub 1 times r to the n minus 1 power. Alright, Cindy, what is my n that I know? 10. Good. So I'm going to cross all those n's out and I'm going to put 10. Sabrina, I'm going to ask you next for the r whenever you're ready. What is r? And that's one of the ones that they give you. Sorry, Sabrina, I like caught you off guard. Abner, help Sabrina. What is r? Okay, r is 1/2. But here's the hard part. Yes.
We can be using decimals instead of fractions.
If the decimal is a terminating decimal, then it's fine. But if it's not, you should technically use a fraction. Good question though. Alright then, Ethan. Instead of a sub 10, what should I really write? Because I can't have two a's. But I know what a sub 10 is.
So just put 7,680.
Yes. Does everyone see that? Instead of this a sub 10, we're actually going to plug this guy in. Alright? So we have 7,680 equals a sub 1 times 1/2 to the what? What's 10 minus 1? 9. What is 1/2 to the 9th power? Give me the fraction, please. Okay, 1 over 512. The reason why I really wanted to do this problem is because how do I get rid of that fraction? Good. Multiply by the reciprocal or the denominator.
Times
1.
512 over 1, which is just 512, and then you can get right to it.
Good. So it's times 512.
And then there's 1.
A sub 1 equals, what is this? A big number. like millions.
393.166.
3,900,000.
I wish I had that much better.
32. I know, right?
16.
Thousand. What?
16.
116. That is my ace of one.
No, it's 60.
No, it's
160. Okay. Yeah, that's huge. So, with that, now I need to write the rule. And the rule part is easy, right? All I have to do is plug in the ace of one that I found and plug in the R. Ace of n equals ace of one, which is 3,932,160 times R to the n minus one. Oh my goodness. Just barely squeeze it in there. Anyway, let's look at this recursive rule for a geometric series. So this guy right here is the second formula under geometric, right? So the first one is E explicit, the second one is recursive. And literally all you have to do here, just like with the arithmetic, all you have to do is just plug in R. That's it. Okay, we're plugging in the ratio. So guys, this one, geometric, easy. Find the explicit rule, that's the first one, right? A sub n equals a sub 1 times r to the n minus 1, right? Did they tell you what a sub 1 is? Yeah. Did they tell you what r is? Yeah. So just plug it in. The explicit rule, a sub n equals 20 times 2/5 to the n minus 1. That's it. This is your rule. So good, right? Can you guys do that for 9a, please? So for the 9a, you should have a sub n equals -4 times 2 to the n minus 1. Yes? Good. So then let's look at recursive rule. Let's go back to number 8b. Recursive is this guy right here, right? The second one. A sub n equals a sub n minus 1, right? Times r. What did I tell you? You only have to plug in what? R. So this is a sub n equals a sub n minus 1 times, what's my r for this? 2/5. If you want to, you can put it in parentheses. There you go. Recursive rule. I mean, isn't that so good? That's all you have to do, literally. Because you're saying the number before has to be multiplied by the r, which is what you do to get that sequence anyway, right? Try it out for 9b. Find the recursive rule for that sequence, please.
Like, this is like the easiest way to
Yeah? Good. I take it you guys like this, huh? Alright. So did we get that for 9b? It's down to 2, right? Alright, Sabrina, will you make sure Abner gets that? Perfect. Alright. So geometric series. The geometric series. Now, remember guys, series is the same thing. It's just a list of numbers, but now they have a plus sign in between because they want you to find the sum. Alright? Geometric series, they have two different sums that you can find. This one is the third formula. And I want you to realize that this has an n. Okay? It's S sub n. That means they're going to tell you how many terms. They're going to say, stop at 30 terms. find the sum up to 30 terms or 25 terms. Like they'll tell you a finite amount, okay? So the third one, they tell you a cutoff. You have the n there. All right. So let's try this. You know, and the thing is, if we look at this formula, think about what you need. All right? Think about the things that you need to plug in to use this formula. So let's make a note for ourselves. What do we need? Look at it. Well, obviously you need the n. They need to tell you up to how many terms, right? So you need n. What else? Yeah, a sub 1. And what else do you need? R. Those three things you need for this. You need the n, the a sub 1, and you need the r. Which is pretty good, right? A sub 1 and the r you just need for all the other formulas anyway, right? Alright, so then let's look at number 10. For this series, find the sum of the first 12 terms. So guys, n equals 12. What is a sub 1? What's the first number in that series?
1.
1. And what is r? So start from the back, divide it with the 1 in front. What's 64 divided by 16? And try another one, just in case. What's 16 divided by 4?
4.
Good. And then 4 divided by 1?
4.
4. So I know r equals 4. Yes? So I'm going to use that third formula on my formula sheet, right? So that is S sub n equals a sub 1 times 1 minus r to the n over 1 minus r. Yeah? So let's plug it in. S sub, let's see, 12 equals, a sub 1 is 1. You know what? When you guys put this in the calculator, you're going to end up splitting up your parentheses. So do you want to just split them up here? Do you want to, should we write it out the way we would put it into the calculator? Like, here, this is a sub 1, right? And then you see this big parentheses, that's technically going to be parentheses divided by parentheses, right?
Can't you put a fraction bar to your alpha y equals an extension? Like, then you can put it in the calculator just like that.
Huh? Wait a minute, hold on. Just like that, right? So since it is, you know, this whole parentheses times your a sub 1, if I were you, in the calculator, I would put this in the calculator first. And then just times it by whatever your a sub 1 is. You know what I mean? Then you never have to like rewrite anything or retype anything. So let me show you what I mean. Because 4 to the 12th is a big number. So what you should do is parentheses 1 minus 4 to the 12th power, right? That's the top part divided by 1 minus 4. Yeah? That's the bottom part, the denominator. Hit enter. Big number, right? And then just do times whatever your a sub 1 is, in this case, which is 1. And there you go. Yeah? There. Look at it like that. Does that make sense? I put in this top divided by that bottom, and then just multiply by a sub 1. Yeah? You can try it out for the next one too. I'm going to just shrink that down a little bit, okay? Oh, alright. Yeah? Alright, so let's try the next one. For the series 2, 4, 8, 16. Find the sum of the first 10 terms. Alright guys, they tell me n equals 10. What else do I know? What's a sub 1? 2. And what is r? 2. Good. Thank you. So let's plug this in. S sub 10 equals, what is a sub 1? 2 times, what is that? 1 minus 2 to the 10th power divided by 1 minus 2, right? And then remember, we're going to do the fraction in the calculator first. Yeah? And then just multiply it by 2. Smaller there so you can see. Yeah? Alright, so what do I have? I have 1 minus 2 to the 10th divided by 1 minus 2. Yeah? Hit enter. Okay. Times 2, because you got to times it by a sub 1. Oh no, went too much. Oh no. Times 2. Yeah, there we go. No, 2046. Thank you, Tom. So the sum of the first 10 terms is 2046. Questions? Alright, so then let's look at the next one. So the next one is finding the sum of an infinite geometric series. Okay? Infinite. So this time I'm going to use the fourth formula. And when do I use this? When they say infinite, because look, it has s, the sum with a little infinity. That's how I know I need to use this if I see infinite, sum of an infinite, okay? Don't worry about this. This is just saying that your common ratio, your R, the absolute value of it, the positive of it, can't be, well, it has to be smaller than 1 or less than 1, okay? Because if it's not, then it's not going to work, is what it's saying. But you guys aren't going to get anything tricky, all right? So just don't let that throw you off. All right, so let's think about what we need for this. What do we need to plug into the formula? Do you have an n? No, your n is infinity. What else do you need to know? R. And what else do you need to know? Yeah. This one's even better. You only need to know 2. And if you don't know one of the 2, you can probably figure it out. That's what they're saying, right? To find the sum of the infinite geometric series. So this one says an infinite, so I know. Okay. I need to use this formula. Equals a sub 1 over 1 minus r. Alright? So then for A, guys, what is a sub 1? What's the first number in my list here? 4. Good. And what is R? 1/2 divided by 1. 1 divided by 2. 2 divided by 4. What would that give me every single time? Yeah. It's 1/2 each time, right? Okay, so let's plug it in. S sub infinity equals a sub 1, which is 4, over 1 minus r, which is what, 1/2?
Yeah.
So when you put this in the calculator, you can just put that in parentheses down there, right? So what is this sum?
Eight.
Got 8?
Yeah.
Anyone else get 8? Yeah, it is 8. Now, I want to see something. I want to see if it works if you don't put parentheses around the 1/2. Because it's a lot of parentheses, right? So what is it? 4 divided by 1 minus 1/2. Because you know I like putting parentheses around my fractions, but in this case it shouldn't matter because of order of operations, but let's see. Yeah. Good. Okay. Perfect. Can you guys, let's try the next one. B. A sub 1 equals what? What's the first number in this list? 1. Okay, this R is a little bit weird. So it goes from 1 to negative 1/4 to positive to a negative. That tells me that it has to be multiplying what kind of number each time? If it goes from positive to negative to positive, my R is going to be what kind of number? Positive or negative? Negative. So let's see. Let's try this. These are weird fractions, but it's okay. You can put it in your calculator, right? Negative 1/16 divided by what? No, 64, sorry. Divided by 1/16. Isn't that the number in front of it?
Yeah.
Yeah? Hit enter. Do math, enter, enter.
Negative 1/4.
Negative 1/4. Or you could look at this and go, well, all the numerators are the same, so what changed on the bottom here? 64 divided by 16, 16 divided by 4, and that's 4. So 1/4. Okay? Negative 1/4. Huh? So let's plug it in. S sub infinity equals 1/1 minus a negative 1/4. Wait, what's a minus minus?
Positive.
Yeah. So put that in parentheses. Plug it in your calculator. Tell me what you get. Try that. You should have 4 fifths for this. Right? Good. It's a lot of information, isn't it? That's not bad, right? Alright, so we're going to try one more thing, okay? We're going to use the sum of an infinite geometric series formula to find R. Because sometimes you don't know R, but they'll tell you all the other stuff. So, infinite geometric series, that means I'm going to use this formula. Right? So it says an infinite geometric series with the first term a sub 1 equals 4. Alright. A sub 1 equals 4. Has a sum of 10. Wait a minute, sum? Is that R or S? S. S, right? Because that's sum. So, sum of the infinite. Okay, sum of 10. They're saying, what is the common ratio? Oh my goodness, they want you to find the R. Yeah? This is actually not bad. You can set this up like a proportion. Fraction equal to a fraction, you can cross multiply, right? The sum, we can plug in 10. What is a sub 1? 4. Over 1 minus r. Right? 1 minus r, just put parentheses around it. And we can cross multiply to find the r. So 10 times 1 minus r equals 4 times 1, which is 4. Right? And then just 10 times 1 is 10, minus 10r equals 4. You writing this down? How do I solve for this r? Subtract the 10 first. Negative 10r equals negative 6. Now, how do I solve for this r? Good. Divide by negative 10. So r equals what? What's negative 6 over negative 10?
Three-fifths.
Good. 3/5. So your ratio equals 3/5. All right? Not bad. Yeah? What else does it have here? Ooh. All right. So I feel like I gave you a whole lot of information today. We have 3 minutes. So how about we just kind of let this all absorb a little bit, okay? I'm going to give you guys a homework. Next class, you guys are going to have your mini quiz for arithmetic and recursive, all right? And then I'll see about the geometric.
I say you're